Hi, everyone. Welcome to the official Cyberdeck workshop. Today, we're going to be kind of going over sort of the various different topics and such like that to actually create these devices. If some of you have not seen the previous recording, kind of discussing how we're going to be making these devices or how necessarily the process of how we came to it, I will be going over some of that right now. Just very briefly. So the idea is that a Cyberdeck is basically just a Raspberry Pi or some kind of computer device, right? That basically interacts with your, or it doesn't necessarily have to be yours, but it can be interacting with a separate system and using that system as a complete interface and nothing else. So basically you are logged in, you are doing work, you are performing tasks on your Cyberdeck, but you don't need a screen. You don't need any kind of special peripherals or anything like that beyond what the host computer has. All you realistically need is just the Pi and then the cable, and then the cable that basically connects it to the computer. Now, what's cool about this setup is that this is pretty tiny. You can fit this in a backpack or your pocket even, right? It's pretty easy to take pretty much anywhere. And the Raspberry Pi 4 is the newer ones is included within this setup as well. What's also really neat is pretty much everything is done through this cable. So powering, serial connections. Yep. Just like what Finn's kind of showing right there, you can even create your own customizable system, which is what we emphasized in our last video, discussing the fact that these systems are incredibly customizable because there is a huge set of community-driven parts and pieces and products, everything that's just been made for these little suckers that is awesome. And it's really well tested and it's heavily documented too. So what's cool is that since we're basing it off of this interface, there is just a ton that we can look past in terms of just like development, right? We don't need to really make too many steps over boundaries or barriers because realistically the entry to making these devices is relatively low, right? That barrier. So today we're just going to be kind of showing you how to set up the proper software, how to make it so that it is flashed correctly, and then of course looking into the profiles more deeply into the software that was created. So let's get to that. So the first thing that we're going to be kind of looking at, let me just kind of pull up my screen here. Okay, so if I share my screens here, so you can kind of see here. So I'm just at a regular browser right now. So what we're going to be using is a software known as PwnPy. And PwnPy is basically created by Mammy82, I'm sorry. And this version is a predecessor, or I'm sorry, the successor of just regular PwnPy. PwnPy, when he was first making it, started to kind of show issues, and in terms of the structure that he created, he didn't really like it because it wasn't really doing well with integrating. So instead, he decided to make pretty much a brand new version, which is called PwnPy Iola. And PwnPy Iola is an acronym for something I really don't know. But what's cool about it is that it has a lot more features packed in this one than it does the last one. Not only that, but it's also updated so that, for instance, certain things such as Ducky scripts and all that kind of stuff won't be an issue, as we in my team did discover earlier in the year when we were working with older Ducky code. So this is the whole website. This is the GitHub page. It's absolutely just packed with documentation on the README. I will go ahead and post this on the chat so that you guys may be able to look at that if you want to. But the main place that we want to be is here. So this is the release page. He has a lot of different configurations and that kind of stuff that are played a role inside of the operating system itself. And it's kind of a pain to do it yourself. So he's really cool about it. And he actually made his own image that you can just flash directly to this SSD card and then basically boot right off of it. And then you have everything all set to go. So I will post this here as well in the chat. And this is the link that you would want to go to. So that's just the release page. And then what you would want to do is you would want to click on this link, the Kali Linux v 0.1.1-beta RP0W Nexamon PwnPy Ioli image.xz. Now, the thing is that when you download this and when it's done, it is kind of a bigger file. So just pay that in mind. When you download this, you're going to notice that there is an extension that, oops, I'm dumb. I'm sorry. I've been sending it to the wrong people. There you go. Sorry about that, guys. So what you do is that when you're here, you're going to notice, so you click on this link, it's going to start downloading. What you're going to notice is that there's an extension file right here, right? So there's the .image, but there's also this additional extension. This is a compression file. So that means that you're going to have to decompress it in order to actually use the image and properly place it, flash it onto the software. And we'll be showing you how to do that. So once you have this .xc file downloaded, it really just depends on what sort of unpacking software you have. If you don't have one, that's no big deal. The one I would suggest to use is 7-Zip. 7-Zip is a pretty great little program. It's very lightweight, and it does support the ability to unpack these files. See right here. So it does support it for packing and unpacking. Depending on what kind of system you have, really depends on what you want. I don't know. Is anyone here running on Macintosh before I continue? Yes, no? If you have Linux, it comes pre-built in. You can use tarball to remove. Okay, yeah. So for you, Manan, since you're using, are you using Macintosh? Okay, Mac. Okay, so Mac does have an XE. Okay, all right, no worries. So that works. Let me know if you have any problems with that. So once you're done unpacking that and you have the .image file, what you're going to want to do is you're going to want to use something called a flasher. Okay. And a flasher is, if anybody has, does anybody have any questions about this? Do they know not, does anyone know not how to use 7-Zip? Are you guys navigating to the proper site? Is there any? macOS has a built-in unzipping capability. That's cool. Okay, cool. So that means that it will be able to unzip that .exe file. So woo for Macintosh, I guess. No, you cannot. I'm not going to repeat that because we're recording. So once you have that unpacked and everything's all set to go, I'm just going to close the chat because I don't want to read that anymore. You should have some kind of etching program. There's a lot of them out there. The one I would suggest is called Balena Etcher, right? And it's let me get you the link for that as well. So you can go to this link here. Yep, that's the one I use. It's pretty awesome. It's honestly probably the one I've used forever. So once you have the uncompressed image file and you have this software, so the flasher, what you're going to want to do is you're going to want some kind of SD card to USB reader. This is a micro USB one. However, you get it down to the point that you can flash information directly to the SD card, whether it be through USB to like SD to micro SD, or from just USB to SD, or any kind of way that you got possible, they all work the same. Just however you can attach the SD card so that you can read the information on the SD card, right? Or vice versa, you can write information to it. Now, once you have that all set up, what Balenci is going to do is it's going to say, okay, I want to choose from a file. So you'll choose from the file, and then it'll say select a target. The target, obviously, is going to only allow you to choose the SD card. For safety's sake, unless you turn it off, it's going to only select the card that is not a part of your boot operating system so that you don't accidentally flash over your operating system, because that would be really bad. So what it's going to do is that you select your file. So the .image file, the one that is uncompressed, you select the target. So that would be your SD card. and then you click flash. And then what it will do is it'll basically just go through, it'll flash, and then it'll re-verify the files to make sure nothing was corrupted in the flashing process, right? Okay, seems pretty straightforward. So then what you want to do is that then you want to take your Raspberry Pi Zero or your 4, and you're going to basically plug it in, the SD card to the SD card slot, right? So you're just going to make sure that it's inserted properly into the device right here, right? You're going to take your cable, and you're going to just plug it into any USB port that is available on your computer. Great. Okay, so once mine is plugged in, and then what you're going to want to do is that for the Raspberry Pi 4, it doesn't matter because it's only one plug-in. It's going to be a USB-C. But for the for USB-B micro that works for the Pi Zero, you're going to want to plug it into the second port, the one that's labeled USB. And on the silk screen, it's going to say USB instead of power. You're going to want to plug it into the USB one. Okay, so we'll just go ahead and do that. All right. Okay. And then what's going to happen is that it doesn't matter which Raspberry Pi you have, they all have indicators. You're going to start seeing a bunch of, if you see a bunch of flashing, your LEDs rapidly flashing, that means it's booting from a disk successfully, right? If it's doing like periodic flashes, that means there was probably some sort of like immediately, that means there was probably some boot problem. I just heard the Windows sound. I don't know if you guys heard that, but that means that it was successfully booted. Now you can see that the LED is blinking every so often. That means the software successfully booted and it's in its waiting mode, right? So that's just the default for this software. Okay. Is everybody with me? Do you have any questions at all? Like I said, you guys can refer back to the old, to the video if there's any sort of like long time questions or anything like that, if that makes any sense. So any questions at all? No, yes, yes, no. Ignore the pots and pans. None so far? Okay. All right, cool. All righty. So then what you're going to want to do is you're going to want to grab a different device than your computer. Because the thing is, we're going to have to interact with the Raspberry Pi software over Wi-Fi. So if you try to do it with your device here, unless your device has two Wi-Fi cards, which in that case is excellent, but if it doesn't, you're going to get disconnected from the Zoom call if you try to connect to the Raspberry Pi through your own computer. So try to grab a separate device. You don't really care if it's connected to the internet right now. Just make sure that it has the capability to connect to a web browser and that it can connect to the Wi-Fi. Okay. So once you do that, so I'll just be using my phone for this. So what we're going to do is that, and this is different for all, it's not going to look exactly the same if you have an iPhone or whatever the case may be, because this is an Android, the superior phone type. But what's going to happen is that once you plug in your Raspberry Pi, you're going to notice that there is the very top one there. You're going to notice there's a Wi-Fi called Pwn Pi, and that's like, it's going to be like in a bunch of emojis. So it's this top one right here. So what you're going to want to do is you're going to want to click on it, and you're going to want to punch in the password for it. So the password is actually written here at the very top. It's right here. So the PSK is May82-Pwn Pi P1. And of course you can look at that from, this part is pretty important. So you just want to punch in that password when you're signing into it. Once you successfully sign into it, right, you're going to notice that you're connected, but there's no internet connection. That's perfectly normal, right? So as long as your device is connected to that device, then that's perfect. So what you want to do is you're going to want to hop on a web browser, and then you're going to want to type in this address, right? So 172.24.0.1:8000. Right? And then just let the web browser load. And then what you're going to do is you're going to be greeted with the configuration layout. This is the layout that you're going to have when you're looking at this device, right? So you'll probably notice that there's a lot of different settings that are when you actually sign in to the space, right? I would show you on my computer. I wish I could, because like the thing is that, but the problem is that I only have one Wi-Fi card and I can't wire in Ethernet to this. So the thing is that I would not be able to connect to this thing if in the case that I did, this Zoom would end because I don't have internet connection anymore. So that's okay. I can basically, well, how can I do this? How can I show you my screen? I suppose I could just instruct you through it, but I know that's not really the best way to do it. So, I don't think this camera goes down any further. Well, it kind of does. Well, I can kind of do it like this because I've kind of gotten pretty used to this layout. So what you're going to notice is that when you're, can everybody see this okay? I can try something else if this doesn't work. Like it's totally up to you guys. Yes, no? Any problems? Let me look at chat. None so far. So I can, well, I can try either. Really, any of it works. If there's any, is there any general concern? Can you lower the brightness a little? Yes, I can. How does that look? Is that a lot better? That looks a lot better, actually. Thank you for suggesting that. Okay, cool. All right, cool. All righty. So once we're here, right? Is there more chat? You can't see everything. Okay. Well, let me think about this. Because the problem is that it's not connected to internet, so I can't cast it, right? Does anyone have any ideas? So, because I was kind of thinking that I was kind of hoping that I would have the capability to like show you guys this without having to.
Sam, you plugged in your Pi, right?
Yes.
By any chance, can you plug it into do you have like remote desktop capabilities to the Pi?
Like currently the only interaction that I have is the USB, right? So that's the only one besides the Wi-Fi connection, which is done through here, but it's an access point. It's not like its own, you know what I mean? So like it doesn't, it's not like its own client yet. I'd have to do that first, which I could do that, but I was having some issues with that. So, and then I have to try to figure out where.
I mean, if anything, what we can do is you can create another tutorial on how to set it up.
Okay.
Where the camera is actually showing your hands, doing everything.
Yeah, I could do that. You know,
like we can actually create a like step-by-step tutorial guide, and we'll take pictures.
You guys are coming with me. It's a good thing I actually clipped this zip tie today because my mom kicked me out of the thing like that. So if we kind of bring it down here.
There we go.
There we go. How's that look?
Exactly.
Yeah, a little bit better.
Yes.
Okay. All right. And then I'll kind of do it at an angle here so you guys can see that. Can you guys see that? You guys can see my really ugly hands. Sorry. I'm not really a hand model. So
can everybody see Sam's,
oops.
Can everybody see it?
Everybody see that pretty well? Yes.
I'd say nod your heads, but obviously I don't see your guys' cameras on. So at least say yes in chat. So at least we have an idea that everybody can see. So yes, Sam, everybody can see. So thank you.
Perfect. All right, perfect. Okay, so here's what we're going to see. So this is what you're going to see as a UI when you're looking at when you're connected to the Pi through the interface. And then, of course, you punched in the address that is found here at the beginning, right? So you can kind of start sort of looking around. So you'll start seeing, deploy stored, reset, store, and then load store. And we'll be talking about a lot of that. So this part is basically under the USB settings. This is everything that has to do with how the device is handled as a USB device recognizable by the host and also by the Wi-Fi client. There's a bunch of stuff that we have to do in here, but for the experiment today, right, we're going to have to turn on a couple things, right? So we're going to have to go to keyboard. We're going to have to turn on mouse, and then we're going to have to turn on custom HID device. All of this has to be turned on in order for our script to properly work and to actually connect to it in the first place, right? You can leave all of this default, but I do suggest that you do change some of it at some point. But some of it's actually kind of fun to screw around with. So you can change the serial number that is recognizable by the host device, the product name that's also, these are all host name stuff, right? Stuff that it's sending to the host computer that it will be able to see when it's connected, right? So once you have all that stuff turned on, you can kind of keep exploring. So this is the Wi-Fi settings. We'll just go over this quickly. It'll say right here, it says that there's an access point running on channel 6, right? So that's just the Wi-Fi channel that's running on, and then that's the name of the access point that you're going to see. So obviously it looks very familiar because that's the one that you connected to in order to interact with this device. You can enable it or disable it, and then you can also enable what's called a Nexon firmware, which is basically dealing with Wi-Fi covert channels. It's kind of a special feature that we really won't be utilizing, but if you do have any questions about it at the end, we can talk about it, right? This is the part where you want to change the working mode. So you can change it between like a station, which is a client, right? So in that case, it just means that it's going to be acting just like your phone or your Nintendo Switch or your device that's connected to a router. It's just a client that's looking for an internet connection that is really only looking for one to be connected to the internet. It's not broadcasting its own per se to be connected to, right? An access point is obviously with if what we're doing right now. So you are connected to the Raspberry Pi through your phone because the Raspberry Pi is simulating an access point, sort of like a router, to make it so that you can connect to it and do stuff. I really like this mode too, which is called client. Will fall over to access point. So if it can't connect to the Wi-Fi successfully, it'll connect to the access point. So in case you punched in something wrong or you're trying to debug and trying to make sure that it actually connects to the Wi-Fi that you want it to, if it fails, it'll automatically turn on access point so you can connect to it and change settings. That part I really like a lot. You can change the channel. You can change the authentication mode, the SSID. So that's the thing that was stated up here. And then you can also change the key. So that was the key that we punched in right here, the Maymay82 PwnPi password, right? And you can change that. So we're just going to leave that all as defaults just for today. Now, this is the Bluetooth settings. I tend to turn this off because the thing is that it's not my favorite thing in the world. It's really just using extra space. I don't like using Bluetooth attacks when I have to, because I just realistically know how unsecure Bluetooth is. So it's just not something I tend to use. We're not going to be using this feature, so you can just ignore it. You can also just turn it off. And then when you want to turn it off indefinitely, you just click on store to make sure that you want to store it under a certain setting. And then what's going to happen is that you can click on deployed store, and then it will just turn it off by default when the system boots on, right? Now, this is the network interface. So this is the part that basically talks about, okay, how per se do I want to be able to connect to this device if the access point has some kind of problem or something like that? You can actually set ranges, dynamic ranges for this device. So say you wanted to perform some kind of special man in the middle of the attack or any kind of, just kind of like back end shell attack or something like that. That would all be done using something that is a little bit more secure and harder to trace, right? So you can use and set dynamic host, uh, um, dynamic IP sets. Sorry about that. Basically, what it does is it makes it so that your IP can change. It's dynamic. It has the capability to, but it's also telling the router, okay, this is exactly what I want it to be. It's also important to set this because if you're on a router per se, if you're on like a network that is not using the same range that you told, you can specify a bunch of different ranges to make sure that when it connects to a different range, it won't, screw up and say like, oh, this isn't in the range of the routers, so the router's just going to kick me out, right? And you don't want that. So especially if you're trying to host it as a client, not as an access point. So these are the trigger actions. So this is kind of special to this software. And what's really cool about it is basically you can set up triggers, right? So triggers are basically any sort of thing you want to do in this software to have it run autonomously by default when you plug it in. You can set up trigger events. So what sort of trigger do you want it to say? When the device is disconnected, when it's reconnected, when it boots up, when it powers down, right? All of this kind of stuff you can specify as a trigger in here. And then you can specify what you want it to do as that trigger. For instance, we can look at this trigger right here. This is the trigger that I made for my code, right? So there's a script called ssh command.js, and we'll be looking at that here in just a sec. Start HIID script, right? So that's specifically what I wanted this action to do. And then the trigger was when the USB gadget is connected to a host. So obviously this is exactly what we wanted it to do in the original project, right? We want it to, when we plug in the device after it boots, it runs a script and connects us. The reason it didn't do it this time was probably because of the fact that I turned that feature off on my computer. I made sure that something like that wouldn't run unless I specified it to. I had to accept it, right? Now, normally Windows devices don't have that on them because they never have to run into that issue, right? You can make it one shot. So meaning like, once it triggers, it happens, that's it. And then you got to go back here and turn it on again. You probably don't want to turn that on because the thing is that you want it to obviously work a bunch of times without you accessing this software every time. So that's quite clear. And then you can of course enable it and disable it, right? You can also stack trigger events on top of each other. So like if you wanted like a startup trigger event, which is kind of the way that it works, there's a trigger event that is technically doing service.start.sh, which actually starts this entirety of the service. This is a software. This isn't a part of the, the lower level operating system, right? So obviously we would need something to make it so that it starts the proper service and all of its stuff, right? And that's what's happening here at the very bottom here, that little gray immutable one, okay? So you can obviously stack them, right? So that's cool. And that's something that we can definitely go over a little bit later. Now, this is the cake, right? This is the part that we want to look at, right? And we're going to be kind of hopping on over to I'm not going to be typing the code on my phone because that's just ridiculous. I'll just be typing it up on the computer. But this is the part, the HID script part, that is where you load and you test your code that you want to create a Ducky script, right? And I don't know if any of you are familiar with Ducky. It's a very, very, very easy language. In fact, I'll be teaching you it today. And it's pretty awesome because the thing is that you can simulate a HID or a human interface device from this Raspberry Pi using this, and it's perfect every time because it's literally just code. It's not a human interaction. There's no human error in this, right? So, and of course you can also simulate human error if you want to, but Ducky itself is basically just software that allows you to simulate a keyboard that's already been pre-written to type, given the fact that it's ran, right? And then of course you can look at logs and then just all the generic settings, what you want to be ran. There's kind of a bunch of different stuff in here. Database backup, system reboot or shutdown. I almost clicked shutdown. That would have been really bad. And then of course the startup settings, which you can modify in the trigger action setting, right? So let's kind of get to the bulk of the main function that we want to write. So when you're in the sorry, I'll just kind of readjust myself here. Hi, now you don't get to see my ugly hands anymore. So the idea is that we would want to create a script that when it connects, it opens up PowerShell, it interacts with PowerShell so that it connects to the SSH properly, and then it finishes it, right? So I will kind of be going through that with you today, and we will just be using Notepad to do that. And of course, you can type this directly onto the interface, or then you can type it in real time and you can copy and paste it. You can do a bunch of different ways. However, you want to get that code to that specific part that I showed you, the HID script section in the PwnPy software. It doesn't matter to me. Either way works for me. Okay. So when we look at Ducky, there is a couple things that we want to immediately specify when we're looking at it. So the first thing that we want to specify is that it has a layout that is built in, right? So there's a lot of different layouts that exist for, these kinds of keyboards, right? I mean, for every language, there is probably a keyboard layout, right? So the one we're going to be using is the US keyboard. We're not going to be using US International or any of that kind of special stuff. We're just going to be using US, but Ducky does have all that built in. You can look into that if you want. So we want to specify as the first thing, the first parameter is the layout is US. By default, it is US, but you just want to make sure that that is what it picks, right? You don't want it to choose the system layout or something weird, right? So now that we have it, you'll probably notice that the code does require a semicolon at the end of every statement. You can chain code, but and you don't necessarily have to include the semicolon, but it's good practice. So please do it. Otherwise, I'll kill you. So the next thing that we want to specify is a function called typing speed. So typing speed is basically just a built-in function that allows you to variate between there's two parameters here, right? The first parameter, right, which is the 100, is basically saying, okay, wait 100 milliseconds for each keystroke, right? You don't want it to be 0 seconds. You don't want the keyboard to just go like, right? Because what's going to happen is that your physical device probably doesn't have the capability to keep up. And not only that, but your Raspberry Pi probably doesn't have the ability to keep up with that either. That's just way too fast, right? So 100 milliseconds is more than enough time for the host system to register the keystroke and for the Raspberry Pi to properly send the keystroke, right? That was just the default. And then the second part, right, the second parameter is basically like it's the additional from the time that you set. So 100 milliseconds. In my case, it's 150, right? There is a 50 millisecond randomized gap that it chooses to make the keystroke. So what it's going to do is it's going to say, okay, well, the baseline is 100 milliseconds for the typing speed, but I'm going to variate another 50 in millisecond time for keystrokes. So if you want to make it seem a little bit more natural when it's typing it in, then use that. Because basically what it's doing is it's using a random variable between 1 and 50 and adding it to 100, and that's the keystroke time, right? That's really, really, really neat and kind of impressive, because the thing is that you can simulate certain kinds of things if you want it that way. You don't, say if you have there are some systems out there that are so smart that realize that if something is being typed at a consistent rate like that, it's going to get suspicious, right? And you don't want that. So you want to be able to make it so that there's some kind of natural human error typing thing there, because you can't remove that, right? That's built into our Raspberry Pis, not that one, right? These ones, okay? So the thing is that you want to make it so that it's just as functionally correct as possible. Okay, so we'll move to the next line. So this thing does have a wait LED repeat function. I really don't know how that works. I haven't had enough time to kind of determine it. So we're going to just leave that because it has something to do with a really special wait time on this software. I really don't know how it works, but if any of you are curious, I will go in and look and see and learn how to use it so that I can help you understand it and also help me. So the first thing is I said, okay, I'm at Windows, right? And I'm just like, how am I supposed to run a program from Windows, from the desktop? If, I have to do all this searching and all that kind of stuff. No, we're going to be using a built-in thing that has been a part of Windows forever. And that is this window right here. I don't know if you see that window at the bottom there, but it is the run window. Okay. And this run window is basically, it's been a part of Windows forever. But since like MS-DOS, because that's the way that it would run programs. But basically what this is it's a automatic run that basically just puts everything at administrative privilege when you run it, right? Crazy enough, a lot of systems don't block this because the thing is that I don't know why, right? Because the thing is that you can run a slew of programs in administrative rights using this, right? Using that particular window right there. So I want to make it so that I can open that window. So how am I going to do that? Well, there is a built-in function that works like that. So the function is press. And then of course we want to specify what we're pressing. So any sort of, if you're pressing the Windows key, so Windows R is what opens the is what opens the run window. So if you want to simulate holding the key down, you want to use press. But if you want to simulate clicking or pressing the Windows key, it's GUI. Okay, that's it. And then of course we want it to also string together R because it's Windows R that does it. You don't need to do any special plus signs. That is quite literally what it types out. It's just Windows R. And that is interpreted as opening the Windows key, right? Clicking the Windows key and clicking R. So now you have the PowerShell window, okay? Or I'm sorry, not the PowerShell window, the run window, okay? So now you have the run window. Now what? Well, you kind of want to give the computer some time, right? So maybe it's not the fastest at opening the run window, and I've run into computers that are like that. So you want to use a function called the delay function. Now, this is measured in milliseconds if you didn't guess. So 1 second, right? That's a pretty good amount of time to give the computer to open it, right? Because it's not a huge program. It's just, an initialization program. It's not like it's all this, it's not like a game or anything like that. So what you want to do is, okay, we'll give it a second's time. So we just type in 100,000 or 1,000, I'm sorry, right? You'll probably notice that I didn't include semicolons. That was really bad of me. I knew one of you guys was going to tell me about that. Okay. So you gave it some time. You gave it a second to basically open the run window after you typed in that keystroke. Okay. So now what you want to do is you want to open PowerShell. So how do we do that? Well, if we look at it here, we say PowerShell, right? No, surely it can't be that simple. Well, it is, right? Once you type in PowerShell to the bottom there, it automatically opens a PowerShell that is specified under my computer. So that's pretty awesome, right? We're halfway there. So basically what we have to do up here is we have to say, okay, type, which is the function that allows you to type something, PowerShell. Okay. Well, what else did I do besides type in PowerShell? Surely I need to tell the software at some point what I typed in, right? Well, we also have to simulate an enter because I hit enter once I typed PowerShell in order for Windows to properly register my command of opening PowerShell. So we're going to use press, right? Enter, and it's in capital. Right. And the reason behind this is because of the fact that enter is a in ASCII. That's actually what enter is, right? That's or not in ASCII, but in the Ducky language, that's the encoding reservation for pressing the enter button on a human HID script. Because remember, the Raspberry Pi is simulating an encoded keyboard, right? So there we have to set presets for what the exact encoding is, so that the Ducky can properly simulate those encoded values, right? So I'm just gonna just kind of shrink this right now because we don't really need that. So once we press enter, right, we hit it, it's all good to go. Okay. So now we have to give time for PowerShell open because it's another program that we have to open, right? So it's going to take some time. So this time may actually be a little bit longer. So let's say delay, 2 seconds, right? That seems pretty straightforward. So now what do we have so far? We set up the US keyboard. We set up our typing speed to have 100 milliseconds between each keystroke with a 50 plus variation time. We started, we plug in the device, it types in Windows R, it opens up the run window, waits a second, types in PowerShell, right? Hits enter, waits 2 seconds. Okay, well, now we're at PowerShell and we're basically just waiting for a command, right? So now here's the fun part, right? This is the part that we need to kind of go back into our network settings and we need to find, right? So the thing is that you'll go back to, before we start writing this part, we want to specifically know what we are connecting to, right? Because the thing is, it's not the same IP address on the USB device. It's different, right? So if we look here under network settings and we click on the little drop down window and we click USB, and I'll be showing this again. You click on the USB section, you can scroll down and you'll notice that the IP address of this device only has one bound by default, and that is the IP address 172.16.0.2. Okay, so we'll keep that in mind, right? So we go back to our code and we say, okay, I know the SSH command, right? I know what is going to be ran here, right? So here's what we do. We type, and for some of you who don't know the SSH command, please speak up. I can tell you how this works, right? You're going to type in SSH, right? That's your, that's the initial command, -L, right? So that's your login. Now, for this demonstration, we're going to be logging into root, but you can create your own user after you do this, because this is just running Kali Linux. So you can create an actual, user on here that you can put in here as your login, because obviously you don't want to sign in as root because that leaves open problems, right? That's not very safe. But just for this demonstration, I'll just be showing you how to do it on root, right? Root. Okay. So now it has an SSH command that is going to be signing in as root. Now we want to specify where it is. So it's 172.16.0.2, right? Okay. So now we have the address and everything like that. So this is the final SSH command. Now we want to give it some time, right? So we want to give it some time to, even though it is connected to USB, it still takes some time to initialize the connection. So we'll give it like 2 seconds, right? And that's a pretty good amount of time. So once we have enough time and it's connected to, it's attempting to connect, this is something that we need to kind of discuss on our own. So the idea is that when you connect to a device for the first time in SSH, some of you may know that you'll notice that there's a thing that you have to accept that says yes, no, cancel, or ignore, right? Now, the thing is that, it says all this junk like, sash key and all that kind of stuff. Well, that stuff is really important because actually what that is it's basically just a check to make sure that when you're signing in through SSH through a device, that it's your device and it's not somebody else who's trying to impose as you, right? And that's very, very, very important because even though they may have the right login and everything like that, they may have tried to mimic your credentials, right? And that can cause a red flag for SSH because it thinks like, hey, if someone's trying to impose as you, it's a different MAC address that's assigned to this IP address. What am I supposed to do, right? And it'll lock you out, right? So you don't want to do that. But as announced to that, most new systems that are being connected via SSH, all this key stuff is stored on the host machine, right? So the problem is that, okay, for a computer that you're going to be connecting to the first time, you have to actually press the yes key, right? That's kind of a problem, because the thing is that that's only going to happen the first time. So here's the way that I kind of see it. SSH allows you to enter in the program or the password. I believe it's 3 different times before it kicks you out, right? So what we're going to do is that every time the PwnPy, you connect the PwnPy, it's going to assume like you're connecting to a new system. So it's going to type W the first time you type in, it's asking for the password. So if you're connecting to a system that you've connected to before, and this script that we're building gives you an immediate error on the first password, don't freak out. Because the thing is that it's basically just typing the letter W, because it's making sure that if the previous prompt is asking for a first time connection, it won't like, type in your password and then give it some weird thing and it just won't work, right? So yes, will the connection time be a little bit slower? Yes, but only by about 2 seconds based on the code that we're going to be writing here. So, all right. So we're just going to go through and we're going to kind of simulate it like we're already in PowerShell, since we already built the whole thing. So the PwnPy is connected. So now we want to test our command to make sure that it works. So we're going to say SSH, right, -L root 172.16.0.2. Ooh, see, that is not what I like to see. What is happening here? 1 second here. Let me just kind of triple check to make sure that I'm on the right settings here. Here we go. My apologies. That's the right one. It's just 1. Sorry about that. I was looking at the wrong dynamic range for the host IP address. That was my fault. I am sorry. So once you have that connected, wait a minute. I think I just discovered something. Sorry, this has nothing to do with what's going on. Okay, now I figured it wouldn't work. Yeah, all right. Well, that was worth a shot. Anyway, so now that we know that the code works, so we tried this, it's going to log in as root under this address. Then we have to type in the password. So the password is just standard. And again, please, I suggest you, please change this, right? Change this to something that is not obvious, which is just root backwards, which is just the default. So it's going to be Tor, right? And once we type in Tor and we hit enter, here's our login screen, okay? So we know that our script, our commands work, right? But like I said before, if this is the first time connecting to a system, it's going to ask, okay, this is the new hash sum that's generated. Are you sure you want to connect to this device? And here's a warning, right? And of course you want to click yes and then enter. And we'll include that in our code. So we'll just exit this for right now. And then we'll just exit my PowerShell as well. So okay, so it's going to be connected. So now at this point, it's going to say on a new system, do you want to connect, right? So you're going to want to say type, literally just the W, yes, right? I'm so glad I'm catching myself. Okay, you just type yes. And then you just hit enter, right? Oh, I'm glad I caught myself too. You want to hit enter every time you run one of these commands, because the thing is that technically you are trying to tell PowerShell that your command is complete, right? So once we hit enter, we have all that and we hit enter, we wait a few seconds for it to connect, then we type W, and then we hit enter as well. Oops. Okay, so once we have that set, okay, it's going to go through and generate the keys, but then we want to wait for the delay just for a few seconds, or a second actually, just to make sure that it is connected. From there, pretty straightforward. Okay, we have the yes. Now we want to type in the password. So type. So the default password is Tor, right? Please change this. If anybody has any questions on how to change this on any sort of Linux system, you can refer back to my old videos, or you can just ask me now. I don't want to torture you by going through that notoriously bad video. So
how do you change the password?
You just type in the command PASSWORD. SSWD, and then you hit enter, and it should automatically allow you to change it from its current to, so whatever user you're signed into, type in that command, it'll automatically bring you so that you can set a new command that is different from the default, right? And this is a system command. This is not, this is not something that has to do with PwnPy. If you want to change the PwnPy login, for the Wi-Fi and that kind of stuff, you have to go to the PwnPy software and change it on the phone like I showed you before. Okay. So excellent question. So when we type in Tor, that's our password, right? Okay. So now the final last command is press enter, right? And that's it. That should be everything, right? Because that's what we simulated when we were going through and typing it, right? So once we have the final, I would be really surprised if this works the first time around. So basically what we want to do is we want to take this text and we want to put it into the PwnPy software. I really don't know the fastest way for me to do this. I really don't want to go through and type it because that's kind of lame. But, well, oh well. I guess we'll just kind of go through and type it. But this command should be just exactly what we want it to do. Maybe I actually, did I? Here, let me see if I saved it. Oh, I did save it. Yes. Yes, I did save it. I'm so happy. Okay, and I'm just checking my code to make sure that everything looks good. I think I became kind of impatient with how quickly it was doing stuff. So I changed the typing speed thing. Don't do that. That's not, you don't need to do that. So I'm just triple checking my code. Make sure I didn't bone you guys by giving something that's not correct. Okay. Everything looks good. I noticed that I did use double quotations when I'm writing the code. I don't think that'll matter for Ducky. Semicolon at the end of every line. Yeah. Okay. That looks good. Okay, cool. So now what I want you to do is does everybody have this code? You can always refer here. I can always here. Is that cool? I just typed it out on Zoom so you guys can have it if you want. So, does anybody else need this up here? I can leave it up here if you want. It's totally up to you guys. Yes, no, maybe so.
I think we're good. Thank you,
Okay,
Sam.
perfect. All right. So what we're going to do is once you have this all pasted onto, the part where it says the HID script stuff, okay, you're going to notice that there's a little button on the top there that says run. Run is basically just like simulating the code if you want to test it, right? So now I'm connected to the PwnPy and I have my code written here. So let's see what happens when I click the run button on this code. Oops. Oh. Make sure that that stuff is enabled. Silly. Okay, let's try it again. I just enabled it. Why you no like? Oh, I know why. I didn't save it. So we'll deploy it. There we go. Cool. So make sure that when you're changing settings on this, now it's actually running the code. There we go. You're connected. So there's your device. There's everything that you have. There's what you need. What I was going to say is that make sure that when you're creating settings on this, that you always click deploy when you're creating a setting, because that actually, that's like saving the settings that you changed onto the device. So that's what deploy means. Okay. So this is it. This is your login, right? This is just a basic system, right? It has everything that a regular Kali Linux distro would have. So here we are. I guess we're in wherever we are. Okay, so we're in the root directory. If we go back out, it's just a full-on Linux system, right? And what's awesome about this is really, besides the SSH keys, which is clearly just useless because that doesn't really tell you anything about the device that's connecting to it. It just tells you the keys that are being associated with that device and then the IP address that it's attempting to do. which is different because the thing is it's local, right? This is a full-on system that you can just carry around with you, and it's yours, right? It's your own distribution of Kali Linux that is being ran on the Raspberry Pi that is being interfaced from a computer device, right? So what you can then do is that once you finish creating this script, you can go back to those trigger events that we were creating, the trigger actions. You can create a trigger action that is associated with your saved code. So I'll kind of run through just how to do that very briefly. We're pretty much completed, right? All we have to do is just make sure that the profiles are correct. So I'll bring you back down here. Sorry about all this movement if it's making you guys sick. I know it's making me a little sick, but so what we can do is that you guys can see this all just fine, I think. So what we can do is we can go to the Actions Events tab. Once we have this code all set and ready to go, right? You have this code all written out. You want to store it by clicking the Store button, and you want to name it something, right? So I name it SSH command, right? So that would be probably the best thing to name it to make it so that, you know, easy organization. Quick note, if you want to overwrite something, like you want to change a file or you want to overwrite and save it, just name it the exact same thing that you named the original save file and it'll overwrite it. Sort of like when you're working with a regular Linux system. So for now, I'll just close this because I know that it's saved as a system, right? It's saved as a command. Now, say I want to refer back to my saves or something like that. Well, what you can do is you can click on Load and Replace, and you can choose between any of the files that you created. So obviously, I want to open up the SSH command.js file. So we click on it, and we click on OK on the bottom here, and it will load. So it'll say at the bottom here, it loaded the script that you're in. And then from there, you have basically all the information that you specified in your Ducky script, right? So that's cool. So now it's actually saved as a file that you can interact with. So what you do is that when you go up here to trigger events, you want to create a trigger. So the best way to do this is to basically just click on add one, right? So when we click on that, we want to, of course, enable it. And there's all these different triggers that we can choose from, right? We can make it so that a service starts. So when this service starts, the USB gadget is connected to a host. It's disconnected from a host. The access point is up. It joins the Wi-Fi network. All of this really cool stuff that you can program, right? And then, of course, what do you want it to do? Well, you can have it write an entry log, run a bash script, run an HID script, which is what we want, load and deploy certain templates or settings. So that's like the stackability that I was talking about. Set outputs on a GPIO pins, or even send values to specific group channels. And groups are basically the way that it handles different kinds of like serial inputs and outputs, right? So what we want to do is we want to start an HID script. So from there, you want to choose the HID script that you specified and you save from the code that we created, right? I don't know if you guys can see that very well here. I'll back up. So there you go, HID command.js. Of course, I want to load that. So we just click OK. So now we have this trigger event that's created. I already have one. Normally you would click on update, but I'm just going to press on cancel since I already have one. And like I said before, you can make this a single fire shot, but we don't want it to do that. So I want this also to be made so when it connects to a host, it'll do that. The reason I do this and not for a service starting, because I know what you're thinking. It's like, Sam, doesn't the service technically start every time you plug in the Raspberry Pi because, like, you know, it's basically just being powered on? Well, yes, but the thing is that I plan to make it so that you can possibly have a battery connection to these devices, which means that it can be on before you connect it, right? This can ensure so that boot up time is a little bit faster in terms of, like, you know, since it's already booted. And the idea is that when you have these devices that are connected, you have it so that it's going to just connect and it doesn't have to rely on a service to be booted. This is just the best way to do it, because the thing is that this is going to work 100% of the time, while in other cases, it probably will only work 70% of the time. So the thing is that once we have this all connected and set up, right? Well, all you have to do is realistically just deploy all the information in terms of the trigger events. So you want to store it as the startup script, which is the default that this software uses. And then what you can do from there is you basically can set that at the bottom here with the master startups template. So as long as you include it in the startup, then it will trigger and then it'll be ready to go, right? That's pretty much everything there is to this device. There's really no other, there is an absolute there's a ton of features that this thing has, right? All kind of dealing with so many different like kind of plugins, right? This device was made to be multi-versatile, right? This software, but we're just using it so that we can make it so that there's an actual system that we can interact with at any given time, wherever you are. You want a tool, you got it, right? This tool costs you $10 to build. Realistically, for the Raspberry Pi 4, it would cost you $40. That's crazy to me. The idea that you can bring something with you that has everything you want is powered by one device. You know, guys, do you have to be doing this up here like right now? What's the... Yeah, I guess.
We were grabbing the green glasses.
Okay. Sorry. Thank you. I'll set it up. Just, you're all good. Another, whatever, 10 minutes, 20 minutes. Thank you. Thank you. Can't wait. So once we have this all set up, we're all good to go. You have your device, your Cyberdeck. It's your own customizable machine. I do plan to do more work on this to kind of make it so it's something more personal, just like what we wanted. But we got the idea down. We have something that basically when it connects, it's ready to go. It plugs in, it simulates, it runs a command, and it connects you to your system, right? Whatever host system you have, because PowerShell is installed on every single kind of Windows I've ever seen. So therefore, that means that any other system that you're probably going to see probably has PowerShell on it. So, I just saw the chat with everybody laughing. I'm done with my presentation. This is it. This is pretty much everything that I discovered in terms of using it. We could go on tangents and kind of talk about some of the different stuff that does exist on this software and just a slew of features that you can use for everything. But I really appreciate you guys. I really appreciate it. All of you guys being here. This was a ton of fun to do. I really hope that everybody enjoyed this workshop, because the thing is that I wanted to create something that would be used as a tool, and my team shared that exact same feeling with me very well, right? We wanted to create something that would work, right? That would be able to come with you and it would be able to easily connect to a majority of the systems that are out there, and to have a tool that makes you feel like you're at home again, because you are. It's your system, right, that you interact with. And I know that so many of you are so curious about the idea of cybersecurity. You need a tool by your side, a companion, something that me and Finn kind of talked about, quite clearly. I personify computers. So the thing is that I have a passion when I look and sort of care for one, because the thing is that it's mine. It's my device. I care for it. And it cares for me because it does so many things for me that help me ultimately become a better cybersecurist. That's kind of my take. And one of the reasons why I was able, along with so many other people, to create such a wonderful device that is so easy and capable. More or less, I didn't create the software, but I wanted to teach many people how to use this software because I felt that it didn't get enough credit for what it's able to do. So I want to kind of take this time to personally thank my team. I know that it's been incredibly tough. And I know how hard it is right now. I understand, right? Which is one of the reasons why I get up and try to make sure that everything's going to be okay with this team, right? I want to make sure that everybody understands at the end of the day what they're doing, because ultimately I know that if you're taught this stuff, you can become smarter than I am, right? Because I don't know this stuff. I just know it because I sit here and I try to understand it by just experimenting with it. And why not just save you the time of experimenting with it and just get to the point, right? The thing that we wanted to. So I just want to say I'm incredibly proud of my team for bringing me to this point by giving me resources, by helping me, giving me, emotional support to get through this. I really, really, really appreciate it. I also just want to thank Fast and pretty much all the eBoard for supporting me as well on getting me to this point. I had an absolute blast doing this research. So thank you so much. And that's it.
We appreciate it, Sam, and thank you. It was a very, very insightful workshop that you just gave.
I hope everybody learned some things. Does anyone have any questions? I'm sure that some people have some questions about this. If they want to ask me it later on too, of course they can. I don't want to make anybody feel like they're, that whole thing where like people feel stupid for asking questions. I don't want you to feel like that. So if you want to ask me them later, you can do that. Thank you
This
so
was
much.
pretty awesome, Sam. Thank you so much. Do you think maybe perhaps you can combine like a list for us of the GitHub as well as some of the commands that you use
Yes.
so that we can actually have like a little tutorial
Of
so
course.
that we can go along with the tutorial of links you have given us as well as following your video. So at
Sure.
least we can go like step by step side.
Yes, absolutely. I will have in that list, I'll have the code. I will have all the links that you need, and then basically just kind of a quick type up for any sort of notes that I need to cover that are maybe not so well spoken, but probably more better typed, right? Yes, 100%. I'll create something for that. I will get that out as soon as I can.
Thank you. Appreciate that.